Artificial intelligence, or AI, is a field that has progressed leaps and bounds in the last few years. Advances in cloud, big data, and machine learning have made business AI applications affordable and cost effective. Due to these advances, AI as a career path has excellent scope. But to become an AI engineer, it is not enough to only learn the technologies in the domain. You also need to understand specific business domains, its challenges, and how AI can be applied to overcome them. Human resources or HR is one such domain that provides a number of opportunities for AI to increase customer satisfaction and improve business performance. How to apply the latest AI technologies to solve problems in the field of human resources management. I will review the scope and challenges that HR executives face. I will discuss the most popular use cases for AI in HR. Then, I will discuss and implement solutions for these use cases. This course uses Python, Jupyter Notebooks, deep learning techniques, TensorFlow, and Keras. That being said, let's explore how to apply AI to HR to solve some of these key challenges. In this video, I will review the prerequisites for this course. The focus of this course is to discuss various AI use cases that apply to a specific business domain, namely HR, and demonstrate. This course does not discuss the basics of the technologies used in this course. Hence, the student is expected to be familiar with the following: AI and deep learning techniques like artificial neural networks, convolutional neural networks, recurrent neural networks, and long short-term memory. Text processing techniques like TF-ID and embeddings, Python programming and Jupyter notebooks, machine learning libraries like Keras, scikit-learn, PyNumPy. If you wish to learn more about these techniques, please review the course listings on this site. Let's now deep dive into understanding. Nearly every business organization has a human resources or HR function. The HR function in an organization deals with its most valuable assets, its people. Whether it's run by a single employee or a large global group, the HR department plays a crucial role in the success of the business. What are some of the key functions of HR? The first one is talent acquisition. They post job advertisements, track candidates, and facilitate the recruitment process. The next is training and development of the employees to help them perform their duties successfully and progress in their career. HR departments also focus on the overall health and safety of the employees. HR drives the compensation and benefit programs within the company to ensure that the employees are paid fairly based on market rates and capabilities. They also run benefit programs like health insurance and retirement benefits. They track and manage the performance of employees, helping them in their work and in their careers. Finally, HR teams also need to ensure legal compliance. They make sure that the organization adheres to the local and government laws and practices. What are the goals of HR? The first goal is to hire top talent for the organization based on technical skills and organizational skills and retain them. They focus on improving employee productivity by providing tools and training. They want to increase employee engagement within the organization. Motivated and happy employees result in happy customers and better business. HR also focuses on developing their top talent, helping them grow in their careers, and nurture future leaders in the organization. So, as you can see, the HR group has many roles and responsibilities. However, they also face a lot of challenges. Let's look at those next. What are the key challenges faced by HR today? The top challenge is attracting and retaining top talent. There is always a huge demand for top talent. In today's connected world, it is easier than ever for others to poach on the organization's talent. Lack of strong leadership is one of the key reasons why employees leave an organization. Good leadership is hard to find outside the organization. Hence, identifying the next set of leaders within the company and nurturing them while not losing them is a key challenge. An organization needs a unified culture to work together. HR needs to define the expected organization culture and ensure that it is implemented throughout the organization. Compensation is a key part of attracting and retaining top talent. HR needs to devise creative ways to compensate employees such that they are motivated to stay and grow within the organization. Organizations today are spread across multiple countries globally, and HR laws and guidelines differ from country to country. Tracking compliance globally is yet another challenge. We reviewed the challenges that the HR function has in the previous video. How can AI help HR to solve these challenges? First, let's start with the discussion around the status of AI today. AI is a domain that has been under research for a few decades now, but it has exploded into the public domain in the last few years. New technologies have made AI affordable for business applications. To begin with, there is a huge amount of data that is being generated. Telemetry, social media, and clickstreams are some of the examples of new types of data that are being captured and stored. Advances in algorithms in the field of deep learning and natural language processing have created new applications for AI in multiple domains. Infrastructure to deal with AI's data processing and machine learning requirements have also grown. Cloud technologies, GPUs, and AI-specific products and services have enabled fast adoption of AI inside the organization. Automation has also grown in all phases of AI, including acquisition, training, and deployment pipelines. This has enabled distributed large teams to collaborate and deliver AI solutions. Finally, the cost of building AI applications has also dramatically reduced, making it a cheaper alternative to existing manual options. What kind of opportunities does AI have for HR? What kind of use cases can it solve? Here are some of the examples. AI can help in talent acquisition. For example, it can automatically screen applicants and filter the list to those who have skills and experience to match the requirements. It can help in talent development by recommending the right set of training programs for a given employee. AI can help understand the collaboration paths within an organization and hence can aid in organizational design. It can provide automated virtual agents for self-service help to employees. It can help understand employee sentiment and thus aid HR to improve employee engagement by focusing on those who need motivation. Now, what challenges exist for AI in HR that would deter adoption? There is usually a lower volume of historical data than desired for the HR use cases. AI needs significant amounts of training data to be accurate, but even large organizations do not have the level of data that AI needs. HR data contains a lot of private and sensitive information like performance and pay. When this data gets into the hands of data scientists, the information is exposed. Employees may not like their private data to be viewed by other employees in the organization. HR is not usually considered a strategic function, so AI projects in this domain may not get the required priority and funding. However, this thought is changing and a lot of organizations consider this as a strategic function now. In the next video, I will review some of the HR use cases that we will be discussing in the rest of the course. In this video, I will preview the use cases that we will discuss in the rest of the course. HR use cases can be considered to be in the following categories. Talent acquisition use cases help in reaching out to prospective candidates, screening them, and helping them through the review process. Self-service use cases help in creating virtual agents who can help employees with the policies and procedures in the company. Organizational analysis use cases help HR understand the collaboration dynamics in the organization and design structures that enable smooth workflows. Training and development use cases recommend training programs to employees and predict their popularity. Attrition management use cases help HR to identify employees who are at the risk of leaving and take preventive steps to retain them. The use cases in this course are of two types: featured use cases and reviewed use cases. In the featured use cases, we deep dive into the use case and build code to execute the use case. The use cases covered here are predicting employee attrition, discovering virtual teams, and recommending training courses. In the reviewed use cases, we review the overall goal of the use case and recommend possible designs. There is no code in these use cases. It's recommended that students build these use cases on their own with their organization's data. The use cases covered here are candidate outreach, automated candidate screening, predicting future performance of employees, employee self-service help desk, and sentiment analysis. For the featured use cases, we will use the following approach. We will start off by describing the problem we are trying to solve in the use case. Then we explore the technologies that will be used for the solution. Please note that we will not be discussing them in detail. The student is expected to be familiar with the technologies beforehand. We then will proceed to review the training data used. Next, we build a model for the use case. Finally, we use the model to predict the target variables for this use case. In the next video, we will set up the environment and exercise files for this course. The first featured use case that we will solve in this course is predicting employee attrition. Employee attrition, especially those of key and star employees, is a major concern for an HR organization. When employees leave, it has many side effects. There is loss of organizational and product-specific expertise, loss of productivity due to new hires taking time to onboard. Sometimes employees have great relationships with customers and that is hard to rebuild. There are also hiring costs and training costs associated. Employees leave due to various reasons. They include compensation, work satisfaction, performance, and issues with their supervisors. The online world had made it easy for outside recruiters to approach employees with better job offers, which can make a content employee leave. How can AI help in this employee attrition? First, we need to collect 360-degree data about the employee's past and present. This includes, but not limited to, the tenure in the company, performance ratings, compensation, and promotions. Relationships the employee has with their supervisor and peers also play a key part. 360 reviews will help understand this. Once the data is collected and associated with both past and present employees, it provides input to build an ML model to predict attrition. Then, HR can take preventive action that is needed. In this chapter, I will show you how to build a simple model to predict attrition. In this chapter, I will quickly review the concept of classification in machine learning and its implementation in deep learning. Classification is a machine learning problem of identifying a set of categories to which a new observation belongs based on a training data set that contains observations for which the category is already known. Classification is the most common type of machine learning problem. Examples include binary classification, like if a customer would buy a product or not, or multi-class classification, like determining the type of customer based on customer demographics. There are also a number of libraries that provide implementation of these algorithms. In Python, the most popular one is scikit-learn. In recent years, deep learning has revolutionized classification with its ability to handle complex relationships and generate highly accurate models. If you're not familiar with deep learning, I recommend watching other courses on this website that explains the basics of deep learning. In this chapter, we will implement employee attrition predictions with deep learning. We will use Keras library with TensorFlow backend for building the classification model. Let's explore the input training data we will use for this attrition use case in this video. The data for employee attrition is available in the file called employeeattrition.csv. You may need to do some work with your organization's data before you can arrive at this format. The file contains feature attributes that could possibly impact an employee's decision to leave the organization. The first column is employee ID. The second column is the total months of experience that the employee has overall. Total orgs work is the total number of organizations the employee has worked so far. Months in org is the total number of months the employee has worked in this organization. Last pay increment band is a scale of 1 to 5, with 1 being the highest. The higher the band, the higher the pay raise for the employee in the last increment cycle. Next comes average feedback based on the 360-degree feedback the employee got in performance reviews. Again, it's a scale of 1 to 5, with 1 being the highest rating. Last promotion years represent the total number of years since the last promotion for the employee. Finally, we have the target variable attrition, which indicates if the employee left the organization or not. This is only a representational data set. For your organization, you should do enough research to include all kinds of data that may possibly influence an employee's decision. Let's now load and process this data in the next video. In this video, we will load up the attrition data and pre-process the data to get it ready for machine learning. The code for this chapter is available in the notebook Code O2XX Predict Employee Attrition. Let's first make sure that all the packages required for this exercise is already installed. We can run the first cell to make sure they are installed. If not, it will install it. We first load the data using pandas into a data frame. Then we review the data loaded, its structure and its contents. Let's run the code and review the results. We can see that the data has been loaded correctly. In classification, it's always a good idea to understand the relationship between the feature and the target variables, especially which feature variables have the most impact on the target variable. We do so using correlation analysis. Here we do a correlation analysis on the target variable attrition. Let's run the code and review the results. We see that the last promotion years has a significant impact on attrition, meaning that employees leave when they don't see enough career growth. Next, we prepare the data for machine learning. We first convert the data set into a NumPy array of type float. This is the preferred input format for Keras. Next, we split the feature and the target variables into X and Y. We leave out the employee ID. We could additionally do center and scaling too if the accuracy is too low. For the target variable, we will use one-hot encoding using the Keras two-categorical function. Since the attrition is Boolean, it has two unique values. Finally, we print the shapes on X and Y. Let's run this code and review the results. We see that there are 1,000 samples. X has 6 columns for the 6 attributes. Y has 2 columns since it has one hot encoding for 2 unique values. In the next video, we will build a model for attrition. In this video, we will build an attrition model with Keras. We start off by setting up the hyperparameters for the model. We will use an epoch of 100 and a batch size of 100. We will set verbose to 1 so that we can see the training results. The number of unique output classes is 2. We will create hidden layers for 128 units. We will also do a validation split of 0.2. This means 20% of the data will be used for validation while building the model. I highly recommend experimenting with the hyperparameters to understand how they impact model accuracy. Now we can create a Keras model. Then we add a dense hidden layer with ReLU as activation. We then add a second hidden layer. Finally, we add an output dense layer with softmax activation. We compile the model with ADAM optimizer and use categorical cross entropy as the loss function. We also measure the accuracy of the model. Then we fit the model for this input data. This set of steps is a standard template for building basic deep learning models. Let's run this code and review the results. We can see that the model ended up with an accuracy of 99%. In the next video, we will predict attrition in Keras. In this video, we will use the model built in the earlier video to predict attrition. In order to predict attrition, we need to get the same set of 6 feature variables about the new employee for whom we need to predict attrition. Prediction then is an easy call to the model.predict classes method that will output a 0 or 1 based on the features. Let's run this code and review the prediction. We can see that the algorithm predicts that the employee will leave. We can also do bulk predictions for multiple employees. We need to create an array of arrays with the inner array representing an employee. The method call is the same. Let's run the code and review the results. I would strongly recommend using additional data points as well as experimenting with hyperparameters and layers for your own model. In the next chapter, we will solve our second use case, discovering virtual teams. In this video, I will review the principles behind organizational design and how AI can help with that. Organizational design is a process of shaping the way organizations are structured to run. The goal is to come up with an organization that will help individuals to focus on their goals and collaborate effectively with one another. It should create seamless workflows and encourage teamwork. Collaboration is one of the key aspects of how businesses are run and work happens. Employee collaboration is no longer limited to their supervisor, subordinates, or peers. They usually collaborate beyond their reporting structure. Solution-level projects require interdepartmental coordination. For example, to deploy a software project for a customer, the development team should collaborate with product managers, operations, technical publications, customer success managers, and the sales engineers. Some relationships require more cohesion than others. Relationships between software architects and project managers across multiple teams is required to build a well-integrated software solution. When multiple teams collaborate, there are a number of possibilities of conflict. Their goals and priorities may be different. They may follow different approaches and processes for execution. Identifying these collaboration hotspots will help in better organizational design. Especially understanding how virtual teams are formed will help in identifying new positions that would enable better collaboration. Examples include program managers or coordinators who can manage these communications. Which brings us to network analysis. What is employee network analysis? Network analysis is a general and popular technique to understand how various nodes in a network interact with one another. In the context of HR, it helps to understand how a group of employees interact beyond their organizational structure. Employees collaborate through multiple channels, including meetings, emails, and chat channels. Information about participants in these collaborations can help identify employee collaboration paths and understand the cohesion between them. In this chapter, we will use network analysis to build a collaboration network and analyze high and low collaboration links. How do we do network analysis with Python? We have a great package called NetworkX. In this video, I will review the key capabilities of this package. NetworkX is a popular Python package for network analysis. It can be used to study the structure, dynamics, and functions of complex networks. Details of this package can be found in the website networkx.github.io. With NetworkX, we create a graph for an organization. The nodes in the graph will be employees. The edges in the graph represent the connection between any two of the employees. The higher the collaboration between these employees, the higher weights these edges would carry. NetworkX provides capabilities to visualize a network graph and analyze its structure. It also has a number of algorithms to analyze networks. They include centrality, clustering, similarity measures, distance measures, and link analysis. In this chapter, we will analyze the employee network for three key metrics. The first metric is clustering coefficient. The clustering coefficient for a node is the fraction of pairs of that node's neighbors who are adjacent to each other. In other words, the node's neighbors themselves have collaboration with each other. How to understand this metric? The higher the clustering coefficient is, the more likely is this node a part of a close group who collaborate well with each other. Usually, we will see this for employees who are juniors as they mostly communicate within their team and rarely outside their team. The next metric is centrality. This is the percentage of all nodes in the network that are directly connected with the node. A higher value means there are more direct connections to this node. This node usually is a supervisor or a leader who collaborates with multiple other employees directly. Then we have betweenness. This is the percentage of times this node acts as a bridge between different groups of nodes. This node connects other nodes indirectly. A higher value means that this employee helps coordinate work between other employees or groups. Typically, a project manager role has this, but may apply to leaders too. I recommend exploring the other algorithms in Network X on your own. In the next video, we will look at the data to be used for employee network analysis. In this video, we will look at the data we will use for employee network analysis. This data is available in a file called chatgroups.csv. Let's review the content of this file. Each record in the file is a list of participants in a chat channel. A chat channel is like a group or team where specific individuals collaborate on a given topic. The number of participants varies by the channel. The same individuals may collaborate on multiple channels. For example, Jeff has a private channel with Stacy. He also has Stacy in 3 other groups. The higher the number of times a pair of employees appear in a data set, the higher is the collaboration between them. It should be possible for you to get this data from your chat, email, or meeting software too. In the next video, we will load and process this data. We will now load the chat groups data and prepare them for consumption by NetworkX. The code for this chapter is available in the notebook Code 03XX Discovering Virtual Teams. Let's run the conda install command to make sure that all required dependent packages are installed in the virtual environment. As discussed in the previous video, we have input data with one record per channel containing multiple employees. We need to reformat and summarize this data set to find employee pairs and the total number of times this pair appears across the dataset. We create a result data frame called employee pairs with columns first, second, and count. We will populate this data frame through this exercise. We open the chatgroups.csv and read it row by row. For each row, we need to extract all the employee pairs out of it. For this, we first sort the row and remove any empty names. Then we iterate over each employee, which would be the first employee in the pair. We then iterate again over the remaining employees to get the second employee in the pair. We check if the employee pair already exists in the employee pairs data frame. If not, we create a new record for this pair with a count of 1. Else, we increase the count for the existing record in the data frame. Finally, we print the contents of the employee pairs. Let's run this code and review the output. We have now created employee pairs and the number of times the pair appears in the data set. In the next video, we will use this information to create a network with NetworkX and display it. Having created employee pair summaries, we will now create a network from this data and visualize it. Creating a NetworkX network is straightforward. We create a graph with the graph method. Then we iterate over each of the records in the employee pairs data frame. For each record, we add an edge with the first name as origin, the second name as destination, and the count as the weight of the edge. The nodes will automatically be identified and added to NetworkX. We then print the summary of the network. Let's run this code and review the results. We see that the network has 9 nodes and 25 edges. This 9 is equal to the total number of employees we have in the dataset. Now let's visualize this network. In order to have better visualization, we want to differentiate the edges based on the count of times the pair of employees appeared in the chat group. So we split the pairs into 3 data sets called E large, E medium, and E small. Pairs that have count greater than 5 are considered large. Those with counts between 4 and 5 are considered medium, and the rest are considered small. We choose the Spring layout for this network. There are other layouts available too. First, we draw the network nodes. We choose a specific size and color for each of the nodes. Next, we draw the large edges and give them a higher width and color them as blue. Then, we draw the medium edges with a smaller width and color them as green. Finally, we draw the small edges and color them as gray. We also add labels to these nodes. We then print the graph. Let's run this code and review the results. As we can see, we have all 9 employees and their collaborations shown in the graph. In the next video, we will analyze this graph visually as well as use different metrics as discussed earlier. Let's now analyze the network we created in the earlier video. Let's look at this graph visually. We notice that Jeff and Lisa are at the center with a lot of collaboration lines around them. On the other hand, Sophia and Rob are on the boundary. We see that there are 2 teams forming here based on the weights of the edges, with Lisa, Mason, Sophia and David on one and the rest in the remaining team. Lisa and Jeff look to be the leaders of these teams with strong direct connections with other team members and also serving as a bridge between the teams. Let's explore this graph with the metrics we discussed earlier in the chapter. We create a utility function that can sort a dictionary based on its values. Outputs of these metrics are dictionaries, so it does help to sort and print them. We start off with a simple degree of the node, which is the number of nodes a given node is connected with. We find it for Mason and print it. Then we find the clustering coefficient of all the nodes. Next, we find the centrality of the nodes. Finally, we look at the betweenness of the nodes. Let's execute this code and review the results. Mason has 6 nodes to which he is connected. Looking at the graph, we can see that he is connected to 6 other employees. Let's look at the clustering coefficient. Rob and Sophia have the highest values. Looking at the graph, we see that both are at the corners of the graph. They have fewer collaborations than others. Mason has the lowest, as he is in the middle between the 2 teams. Let's look at centrality now. Jeff and Lisa are the highest. As we see from the graph, they are in the center and have maximum collaborations. Rob and Sophia have the lowest. Lisa and Mason are higher in the betweenness score. They form the bridge to enable collaboration between others in the network. Rob and Sophia have scores of 0 as all their connections have direct links between them. When the number of nodes is higher than, say, 100, it is not possible to visually explore these relationships. These metrics help to filter, understand, and extract key players in the network. In the next chapter, we will explore the use case for recommending training courses for employees. One of the key areas of focus for HR is to identify the right training and development programs for each of their employees. In this chapter, we will discuss a specific technique to recommend training programs to employees. Employees need training to bridge their skill gaps, both for their current work as well as for the next level. Training and development plays a huge role in generating self-confidence and employee satisfaction. It reduces attrition. HR organizations need to identify skill gaps for employees and provide training programs on a continuous basis. How does HR identify training needs for each employee? This input can come from the employee themselves, their supervisor, or requirements specific to the job role. These require information collection and consolidation. Another way to do this is to look at training programs that are well liked by similar peers. AI can help analyze ratings provided by peers to different training programs and choose the programs that a specific employee may like. We will explore this use case in this chapter. There are of course other ways AI can help to predict training needs. In this video, let us explore how user item recommendation techniques can be used to recommend courses to employees. User item recommendations is a collaborative filtering technique used in machine learning. This technique first identifies users who are similar to each other based on the items they have in common. Then, for a given user, it recommends items that other similar users liked or bought. This technique is used in a number of e-commerce websites to generate product recommendations for users. There are multiple implementations available to do user item recommendations. In this use case, we will do the same using deep learning and word embeddings. Let's do a quick review of word embeddings. Word embedding is a language modeling and feature learning technique that is becoming more and more popular in deep learning, especially with natural language processing. It converts text into equivalent numbers and represents relationships between words using numeric scores or values. When provided a data set, it understands how different words relate to each other, with words that occur together getting higher similarity scores. In case you are not familiar with word embeddings, please refer to the wiki article and also a number of other web sources available. In this use case, we get creative. We will use employee IDs and course IDs as words and build embeddings to discover relationships between them. In the next video, we will review the input data to be used for this course. In this video, I will review the ratings input data that will be used for recommending courses to employees. The input is available in the file employee-course-ratings.csv. The file contains the ratings that employee gave to courses that they took previously as part of corporate training programs. For each rating, we have the employee ID and name for the employee who took the course and the course ID and course name for the course. The ratings are provided in the range of 1 to 5, with 5 being the highest. We will build an algorithm to predict the possible rating an employee will give to a course he has not taken so far. The assumption is that if the employee finds the course suitable, they will provide a higher rating. In the next video, we will pre-process this data. We will prepare the ratings data for embedding in this video. The exercise for this chapter is Code 04XX Recommend Courses to Employees. First, let's make sure that all the required dependencies are installed in this virtual environment by running the install command. Now, let's load the course employee ratings.csv file into a pandas data frame. We then review the contents to ensure correctness. Let's run this code now. We can see that the file is correctly loaded. Next, we build two data frames with a unique list of employees and courses. We first build the employee list by selecting the unique list of employee IDs and names from the ratings data frame. We then do a similar exercise for the course list. We then print the sizes of these lists. Let's execute the code and review the results. We see that there are a total of 638 unique employees and 25 courses in this dataset. Now, we will start building the embedding layers in the final model. We first create a Keras input for employees called emp_input. This would contain the employee ID from the ratings data. We create an embedding of vocabulary size 2001 with 5 features. We will use the employee IDs directly as the indexes to the vocabulary instead of creating an ID name mapping. We then flatten the embedding to create an emp_vect vector. Note that we are just setting up the code here and have not done any actual processing. We do a similar exercise to create a course vec by using the course ID as input. Note that the course ID is a continuous number from 1 to 25. In case you are not familiar with how embeddings are built, I strongly recommend reviewing other literature about this topic. Finally, we merge the two vectors using the concatenate function. Let's execute this code now. In the next video, we will build a model using embedding definitions we have built so far. We will now build a Keras rating model based on the embeddings we built so far. Our recommendation strategy for this example is as follows. We build a model that can predict the rating given an employee and a course. Then, when we need to recommend training for a given employee, we predict ratings that this employee may give to each of the courses he or she has not taken. Then, we recommend the courses with the highest predicted ratings. First, we split the ratings data into training and test data sets with a 10% holdout for testing. We now will continue to build the model. We create a fully connected dense layer with 128 units and an activation of RALU. We pass the merged vector we prepared in the previous video as input. We create another fully connected layer with 32 units. Finally, we add a dense layer to predict the rating. We want to look at the absolute rating number and not a category, so we don't use softmax. Alternatively, we could also use the ratings as a category by passing a one-hot encoded rating value and add a softmax as the final layer. Now we create the model where the input would be the emp input and the course input placed side by side and the output being the model output. We compile the model using Atom Optimizer and print its summary. Now we proceed to fit the model. The input X contains the employee ID and the course ID that would map to the emp input and course input respectively. The predicted Y would be the ratings column. We will use 25 epochs and also do a validation with 10% of the data. Once we build the model, we will also evaluate the model using the test set we built earlier. Let's run this code and review the results. We are minimizing loss, which is mean squared error. We can see that the value drops as the epoch continues. I highly recommend experimenting with more input data and the hyperparameters and layers to see if the loss can be further minimized beyond the 0.37 it is showing here. In the next video, we will proceed to use this model for recommending courses for a specific employee. We will recommend courses to employees in this video using the model we built earlier. In order to predict the rating, we need to pass as input two pandas series. The first series has the list of employees and the second has the list of courses. These two series have to be of the same size. To predict the rating for a single employee for a single course, we do the following. We want to predict the rating for employee number 1029 for the course number 8. So, we need to create two panda series with the employee and course IDs there and call the predict function. Let's run this code now. The predicted rating for employee 1029 for course 8 is 4.43. Now, how do we recommend a list of courses for a given employee? We will do that for employee Harriet Laughlin. We first need to get the corresponding employee ID for this employee from the emp list data frame. Then we get a list of courses this employee has already completed from the ratings data frame. By comparing this list with the course list, we get the list of courses the employee has not taken so far. This is the list of courses for which we need to predict the ratings. In order to predict, we need to have both the emp input and course input to be of the same length. So, we create the emp dummy list by repeating the same employee ID to match the size of new courses. Now, we can pass these two data series to predict the projected ratings for each of the courses. We then flatten it to return a vector. We then print this flat vector. We use argsort to get the indexes sorted by descending value and then iterate over the top 5 courses. Based on the index, we will get the course ID, course name and the ratings. We now print them in descending order. This is the recommended list of courses for this employee. Let's execute this code now. So the recommended list of courses in descending order for this employee would be mobile development, help desk, project management, and so on. We can of course do this exercise for multiple employees as a batch and collect the outputs. This completes our featured use cases. In the next chapter, we will review additional use cases for HR. In this chapter, we will review a few more use cases for AI in HR. The first one is predicting employee performance. While hiring a candidate, the most important question to ask is, how well will this employee perform in the future? We would use a similar consideration for employee promotions. Past history is the best indicator of future performance, so we should look at feature variables about past performance to predict the future. A number of additional factors also influence the future. This includes skill set, motivation for the job, a match to organizational culture, and adaptability to the new setup. This is usually an implicit consideration during the interview process, and the hiring manager makes the decisions. But we can use AI to look at the employee's credentials and predict the future. This will help make the process more normalized and rational. So what is our goal? Given a candidate's past details and interview performance, predict the candidate's performance score for the next 3 years. For every candidate, come up with a score from 1 to 5, with 5 being the highest. What input data would we need? We want data from the past about how the candidates performed in the interviews and how well they turned out later. We want to capture as much data as possible about the candidate's past as well as the candidate's interview performance. References, social media recommendations, etc. also play a role. We also will use a target variable of a performance score, which could be the average score for performance reviews. What is the design here? We are mostly dealing with structured data, and predicting a score is a regression problem. This can also be handled as a classification problem by only having 5 unique ratings. Having a continuous score allows capturing of more variations in the performance. What preprocessing is needed? We need to center and scale the feature variables. To build the model, we have multiple options. We can use scikit-learn with linear regression, or we can use a simple artificial neural network with dense layers. Since we are predicting a continuous variable, we won't use softmax activation. This first reviewed use case is a simple model. We can add a lot more feature variables specific to the organization that may relate to the candidate's future performance. We could also determine the future performance score based on multiple performance indicators like performance reviews, percentage exceeding the target, etc. In the next video, we will review another use case, candidate outreach. The next use case we will review in this video is candidate outreach. In today's hiring process, it's no more about just publishing a job advertisement and expecting the candidates to apply. To get the best candidates, the HR personnel needs to identify prospective candidates and reach out to them to invoke interest. You might have seen this yourself in your social media interactions. Outreach is an expensive process and requires a lot of work. To get the best outcomes, it's important to shortlist a set of candidates who meet the requirements as well as have a high probability of responding to your request. When scouting for prospects, social media and public profiles today play a key role in understanding the candidate's skill set and potential interest in the position. So, what is the goal for our use case? Given a candidate, we need to identify if the candidate would be interested in applying to this position. What input data can we gather? We need data about past outreach activities and the candidate's responses. Most of this data comes from social media. It includes education, years of experience, technical skills match, recommendations, and social media posts. This data is usually in text form and would require pre-processing in order to arrive at this data set. Things like technical skills match can be done by comparing the required skills list with the candidate skills list. We also need a target variable, which is if the candidate responded positively to the outreach. What is the design here? The problem deals with structured data. It's possible that this structured data is derived from text processing of social media content. It also is binary classification. We could possibly do this as a regression where we predict a value from 0 to 1, indicating the probability of a candidate's positive response. What preprocessing is needed? We need to do some text mining to derive the scores and matches. We have to one-hot encode the target variable. Centering and scaling is also recommended for the future variables. For modeling, we could use a simple artificial neural network with a few dense layers ending in softmax activation. This would predict a 0 or 1. An alternate approach could be to use embedding and take the entire social media profile as input and try to predict a response. In this video, we will review using AI for automated candidate screening. Today, most open positions are advertised on job search websites. These websites make it easy to apply for any job with one-click applications. So, each position ends up with hundreds of applications with a number of unqualified candidates. How do we review through these hundreds of applications to find the right candidates? AI can come to the rescue. We can use machine learning to screen and identify resumes that are similar to the job requirements and then choose the most matching resumes for manual reviews. This will save a lot of time and effort. So, what is the goal for automated candidate screening? For each candidate, come up with a match score in the range of 0 to 1. Higher score means better matching between the job requirements and the candidate's resume. What data will we use? We are going to use individual resumes as input and the job description as the reference. We will compare the job description for similarity with the individual's resume and come up with a match score. There is no training data needed for this exercise. What is the design here? We are dealing with unstructured text data, and resumes can be in different formats. We are going to come up with a similarity score for each document with the job description. We have multiple options to do this in machine learning, and we will focus on one approach here. We start off by cleaning the input text, removing stop words, and doing lemmatization. We then create a word vector for each resume. We can additionally filter these word vectors to pick keywords that match skills. The same pre-processing needs to be done for the job description also. What modeling will be done? Latent semantic analysis is a great technique that can discover similarities between documents. It builds a latent semantic index that carries similarity information between documents. We can build this model to generate similarity scores. These can then compare to the LSA scores for the job description and pick out the matching resumes with the best similarity for the job description. We can also combine filtering based on text with filtering based on structured data like years of experience to build a hybrid candidate screening system. In the next video, we will review another HR use case, Employee Virtual Assistant. We will discuss the Employee Virtual Assistant use case in this video. Employees frequently contact HR for questions regarding policies and procedures through email and chat. Most of these policies and procedures are typically documented in guides and FAQs. But human help is needed in order to understand the natural language questions from the employees and map them to corresponding documentation. AI can help understand these questions and map them to answers. What is the goal for the use case? Given a question from the employee, find the best guide link that has the answers to the questions. For example, if the question is, "What are the deductions in my payslip?" map it to an FAQ on payslip. What is the input training dataset? The input dataset needs to be a series of questions and their corresponding links. It is important to have a good corpus of questions. The same question should be asked in different ways, like, how do I download my payslip? What is the payslip download option? This will help the algorithm to learn about different ways in which a question may be asked, and it can then answer a new form of the same question. What does the design look like? This deals with unstructured data and would require text processing techniques. It is also a similarity problem like the previous use case. We are trying to find questions that are similar to the question asked by the employee. Once we find similar questions in the training set, we can then provide the corresponding links to the employee. What pre-processing is needed? Typical text pre-processing techniques are needed here, including text cleansing and stop word removal. We then convert each question into a word vector. How do we recommend a guide link? We build a similarity model with all the questions. It can be either a TF-IDF model or an LSA model. This model can be then used to find similarity scores between any two documents. When a new question is asked, find the nearest question to this question based on the similarity score. Then return the corresponding guide link for that question to the employee. In the next video, we will look at our final use case, sentiment analysis. In this video, we will review the final use case in the course, sentiment analysis. HR usually has forums and communication channels where employees can post personal and job-related questions and grievances. This could be about their supervisors, peers, working conditions, or compensation. Understanding sentiments in these posts will help HR prioritize the responses. It is important to focus on those with negative sentiments and take action, as delays may impact employee morale and lead to attrition. AI can help understand sentiments from text. What is the goal of sentiment analysis? Given a message from the employee, identify if the sentiment of the message is positive, negative, or neutral. What input data do we need for machine learning? We need messages that are already labeled with the corresponding sentiment. This is usually done manually for past data to generate a training set. What does the design look like? This is a text processing problem again and deals with unstructured data. It is a multi-class classification problem since we are trying to identify a sentiment class for the message. What pre-processing is needed? We need to do standard text pre-processing, including cleansing, stop word removal, and lemmatization. We would build a dictionary with a unique list of words in the corpus. This would help in building custom embeddings for the problem. We also have to do one-hot encoding for the target variable, namely sentiment. In order to build a good sentiment analysis system, we will build a custom embedding with the corpus we have. We then can use convolutional and max pooling layers to reduce the dimensions of the data. Finally, we can use dense or fully connected layers before finishing with softmax activation to predict the sentiment. Other options for sentiment analysis also exist, like bag of words. This completes our discussions around the various use cases for HR. In this chapter, we will quickly review some of the recommended best practices for building and serving AI solutions. We start off with model development best practices. AI and machine learning have changed the way we build software. Data was never a key part of software development. With machine learning, training data has a crucial role to play in building AI solutions. Treat training data like software code. Keep data under version control. Use tools like DVC for this. Also, make sure that all processing done on data is repeatable by keeping track of the code that acquires, cleans, and transforms data. Machine learning models also evolve over time. Treat them also as code. Keep track of the version of models built and the associated hyperparameters. Models should be recreatable. Track performance of machine learning models as you conduct experiments with data and hyperparameter tuning. Periodically evaluate results of experiments and improve and reassess progress. It's very important to keep sight of the end goal and be ready to change course if experiments are not yielding the desired results. Finally, ML today has become open source, not only with code but also pre-trained models, architectures, and hyperparameters. Use out-of-the-box models wherever possible and use transfer learning to build upon existing models. Institutionalized AI needs a machine learning platform to organize data, collaborate among data scientists and engineers, evaluate models, and automate deployments. As machine learning has evolved over the last few years, processes and products that take care of infrastructure, pipelines, experiment management, and deployments have emerged. To be able to build and manage AI solutions over a long term, it is recommended to have a learning platform for the AI team. This learning platform should take care of the following functions: data versioning to keep track of data and changes to it over time, automated and repeatable data preparation and feature engineering, creation of experiments, collaborating and keeping track of results and models from these experiments, automated pipelines to deploy new models to production and also roll back already deployed models, collaboration among data scientists and engineers to create, review, and approve work. Today, a number of products have emerged on the horizon, including Kubeflow, MLflow, and Airflow. It is highly recommended to build a data platform using these products to manage AI work in your organization. One of the most critical yet overlooked area of machine learning is model serving. The ability to serve models at scale and yet in cost-effective ways is a key success factor for AI projects. Today, GPUs provide multi-fold processing power for machine learning. However, they are most useful in model training activities. They may or may not provide a significant advantage in model serving. It's highly recommended to compare costs between CPU and GPU implementations for serving, as using 10 CPUs instead of one GPU may be cost effective overall. Use a model serving platform like TensorFlow Serving to harness out-of-the-box functionality and scaling. It is important to track model inference or prediction performance over time. Both accuracy and speed of predictions should be tracked to ensure that they continue to perform as desired. Model drift happens when models lose accuracy due to new types of real-time data. Model drift needs to be tracked and assessed. Pass back serving data to the learning platform. This provides feedback on model performance as well as new data for the model to retrain. Automate model deployments and rollbacks similar to code. Building CI/CD pipelines for models is a good option. Use deployment options like canary and blue-green deployments for new models to ensure that they don't have a negative impact on production. Security and privacy has become one of the biggest considerations for AI. There are significant concerns from employees and customers in using their private data for training models. There are new legal requirements for data privacy, including GDPR in Europe. There are industry standards like PCI and HIPAA that require data to be protected. There is also the risk of data theft. These requirements have led to strict security procedures that deny access to this information for data scientists. Data labelers need to look at this information to create accurate labels. How do we enable AI in this environment? Here are some recommendations. First, create a secure machine learning environment with restricted access. Deny access by default and only allow required personnel to access data. Use sensitive data for machine learning only when it's absolutely required. Anonymize and obfuscate sensitive data when possible. This can be done by mapping actual names to pseudonames while keeping the required trends present in the data. Seek employee and customer approvals through contracts and agreements. Create stringent procedures for employees, contractors, and third parties if they need access to sensitive data. Ensure that manual and automated procedures and checks are in place to prevent data theft.